All right, hello everyone. I'm finding out more and more, there's a lot of questions around the torch. How does the torch go together? Assembly issues. How should the electrode be sticking out? Just some details around the torch. Give you an idea, we're using a torch in class, very much like this one. You can see how far the electrode is sticking out there. This is a smaller cup, I believe it's a number 4. In lab, we're actually using we are using actually a number 6. Different side electrodes, what do those numbers mean? So let's go on and get into this. A couple of other torches we could use. This is called a lens. You can see how the electrodes stick out much further because you can do that with this one. Let's say you have a tight access where you're gonna come straight in. This torch comes straight in just like so. Has a number 6 on there. So that's 6/16 of an inch. The other one was 4/16 of an inch. And then finally, just small areas. We can use small torches like this. If this is still too big for you, we can also use a little tiny torch like this. Depending on the thickness that we're using, and the materials that we're welding, we can go with a smaller or a larger electrode. Common electrode sizes, 1/16 of an inch, 3/32, and 1/8 of an inch. Generally, the electrode size needs to be commensurate with the thickness of the plate that you're welding. So let's talk a little bit about the electrode and how this is supposed to work. You'll see this electrode here. So this is a EWCE2. This is a serrated electrode. You can see we don't sharpen the end that's painted. We want to know what this electrode is because there's so many different kinds of electrodes. This electrode, our grinding is setting up right now to do about a 1 diameter length taper on that point. Not very big, focuses some. That's kind of more for high heat. To really get good focus, you can see on this one here, much longer, sharper tip there, just to give you the two side by side for comparison, so you understand what I'm looking at. The amount that this one's sharpened is over a greater distance than the other. The longer the point, the more you can really focus that energy exactly where you need it. The shorter the point, kind of the longer it can take high heat. So it just depends. Sometimes using a bigger electrode with a nice sharp point works. It just depends. Sometimes bigger electrodes have a hard time emitting electrons and starting the arc early, so it takes more heat to do that as well too. So any number of different things. Generally speaking, a gas cup, so this is a very finite, this is for a tight area, this is number 4, 4/16 of an inch. This electrode can stick out half of this overall diameter. So a radii is another way to look at that. But half of that diameter, let me give you a reality on that. That is going to look like half of this diameter. So this is fairly close, probably not a T-joint cup. This electrode can comfortably stick out, and what I mean by stick out is how far it sticks out of the gun there. Can comfortably stick out about that far. We're starting to get a little close to its maximum point there. After that, there's not enough shielding gas, and we have some issues. That little nozzle there for you to run up the pressure level, we could probably shield about that much electrode. In lab, that's a pretty good amount. Now, you always want the electrode sticking out of the gun. More and more in class, I'm seeing people run around the electrode sticking in the gun, like so. That doesn't work out so good. Now this cup gets really hot, you have no focus, you gotta use a lot more heat to melt the material. This just becomes more of just kind of a bazooka. It just blows a ton of heat. So you gotta have this sticking out. So we're just using the electrons that we want, not just an excessive amount of arc heat, just like so. You use too much arc heat, this is what we end up with. This is an electrode fused to the copper tip. That's because somebody did not have the electrode sticking out far enough. This is like a total throwaway. Everything gets thrown away here. In addition to that, the cup gets really hot, and then you touch against something and it blows in half. Don't want that either, not very useful. So just to avoid waste, you need to have it sticking out somewhat out of the gun. Eventually you're gonna touch it, we're gonna have to chip it, get that ball off, sharpen it again. We'll show you some techniques for that in class. We'd like to do that for now, but show the techniques later. So again, just common gun like so. I did the breakdown in another video. Now this is a gas lens. This little bit actually screws on to another piece, and this is called the swirler. What this does, this little gas lens here, this little swirling tip, is it allows for the gas to come out through this screen area, and it keeps it rotating, keeps it nice and tight, kind of rifled out there in front of the gun. When you screw this thing together like so, nice tight fit there so it doesn't bring in any oxygen around your argon, this shoots off a tube of gas, very concentrated. So in so doing, we can stick this electrode out a lot further. These are basically limited based on how much gas pressure you've got and where you're trying to get in. These are very useful when you're trying to get into a really close spot. So you've got a couple of tubes that come really close together. You're gonna need something like this to get down in there nice and close like and actually still be able to weld just those two tubes. So gas lens, a lot of people just use these exclusively. They do burn up a lot of gas. Right now we're running 14 pounds per square inch on our gas. Not very much. With these you can run upwards about 45. You start getting too much pressure on your gas and your weld's too close, you start having funny looking welds again because you start causing some rippling and some other effects. So gas lens, gas cup. This is called a pencil torch because it just comes straight in. There is no handle. The handle is actually down here as part of the continuance. And because they know that turbulence on that puddle is a problem from too much gas pressure, they actually have a way that you can choke off how much gas is coming through right here, another adjustment. This little tip would go onto the same torch. This is just really close, but really low, probably about 40 amps is all we can do. This is about 120. We can get about 200 if we use the right electrode out of this one. Really, if you're going about 180 or above, you're gonna want to use what's called a water-cooled torch. We used to have these in the old lab. We don't run them so much anymore. Water-cooled torch varies from an air-cooled torch, and that uses water. So here you can see we have, this is our argon, our electricity, water in and water out. Just like so, water just circulates over the top of that. This torch just looks like this on the inside. We just take that tube, wrap it around the top, water in, water out, not complicated. This is for a high amperage, and we're gonna be welding all day. Our torches are actually air-cooled, like a lawnmower. And that's why we run so much argon through them, to try to keep them nice and cool so we don't melt the pieces. But they do get hot in your hand if you're welding for a while. They're really made for that kind of 120 and less amperage. All right, key here, electrode needs to stick out. How far depends on whether you have a cup or a lens. You guys are going with a cup, so no more than half the distance.